everyone, I'm Helena Pereira and I'm here to present our work entitled Discrimination between Alzheimer's disease and frontotemporal dementia subtypes using imaging features and machine learning to understand the role of the hippocampus in these dementias. Some dementias, for instance Alzheimer's disease, and in particular mild cognitive impairment, Alzheimer's disease related, and frontotemporal dementia can present very similar symptoms and size at the very disease onset. And distinguish these diseases can be quite challenging. Therefore, the identification of the brain regions specific to each dementia type can be very useful to adequate treatments and to study disease progression. With this in mind, in this work, we aim to discriminate the different types of dementia using machine learning, and we also assess which regions differentiate these diseases. For that, we use data from Alzheimer's disease, mild cognitive impairment, Alzheimer's disease related, a frontotemporal dementia, the behavioral variant, and also a semantic variant of primary progressive aphasia. We extract data from this dataset from two datasets, from Alzheimer's disease neuroimaging initiative and also neuroimaging in frontotemporal dementia. We extracted magnetic resonance imaging, in particular T1 weighted, from all of these subjects. Then we extracted the volumes, the features that we want to classify using our algorithm of machine learning. We extracted these features using FreeSurfer, and the volumes were normalized to the total intracranial volume to mitigate the fact that different subjects have different brain sizes. We extracted the volume of the hippocampus and we summed bilaterally, and also the internal cortex, amygdala, inferior lateral ventricle. We summed bilaterally as well the left and right entorhinal cortex, left and right amygdala, and so on. And then we extract the volumes from these regions here. These regions belongs to the brain cortex, and we summed all of these regions into one to create the cortical volume. Then we perform the classification between these two groups, Alzheimer's and frontotemporal dementia, and we compare by binary classifications. We decide to use leave one out cross-validation because we have a reduced dataset size. And since Alzheimer's disease can be diagnosed very late, we only used age and sex match dataset. So this subject here, Alzheimer, and all of the sample has lower than 70 years old and also have the same sex. Here are our results. We can see that for discriminate Alzheimer versus the behavioral variant, we cannot achieve with hippocampus. We only got 65% of accuracy, and which only slightly increases when you use only the threshold of cortical. What we did in the classification was to classify the hippocampus alone, and then entorhinal alone, and then combine several variations and combinations of these volumes to extract the best model that can differentiate the diseases. So here we are comparing the hippocampus with the best model discriminating these two groups. And we can see that here in the box plots, they have quite similar volumes. The distribution is quite similar, and there were not statistically significant differences. For this case, we got statistical significant differences. In particular, we can see that the behavioral variant is slightly lower than the Alzheimer's disease patients, and it has a statistical significance, as we show here. So makes sense that although not with a high accuracy, even with statistics and with machine learning, you can see that there are differences between these two groups. In regards to differentiate Alzheimer from a semantic variant, we can see that we also did not obtain the best results with hippocampus. The result that best achieved the highest values with the combination of these regions. And when we see the plots, we can see as well there is no statistical significance differences between these regions, although the patients with semantic variants tend to have less or lower volume in comparison with Alzheimer's. And here we can see each one individually. In this model, these was the three features that were used to compare the two groups, we can see that anterior renal cortex and amygdala had the lower volume compared to Alzheimer. And in contrast, we can see that Alzheimer has lower inferior lateral volume ventricles compared to Savantic variant. So here we can say that these two dementias can be discriminated using imaging features. And then we can study the mild cognitive impairment with the other types of dementia, and we can see that hippocampus has 66%, although, and we also can see that with this accuracy, we have differences between the groups. But the highest result was achieved with the cortical one with 85% of accuracy. And here, when we study these differences, the cortical, I mean the combination of the cortical regions, we can see that the behavioral variant has a lot of atrophy. The volume is reduced in this case compared to the mild cognitive impairment in the Alzheimer's disease. So in this case, that when the disease is quite subtle, especially in mild cognitive impairment, we can see that the behavioral component is more affected than mild cognitive impairment associated with Alzheimer's disease, but not which can also be seen in the hippocampus, and makes sense that in these states the hippocampus is not yet much affected as in Alzheimer's disease. And here, finally, the last case to compare mild cognitive impairment with the semantic variant, we can see that this was the case with the highest accuracy. Once again, the amygdala, the hippocampus did not achieve the highest value. The result was achieved by the amygdala. And we can see that for the hippocampus, here, this is quite the same as the previous case. In this case, mild cognitive impairment has the highest hippocampus volume, and the semantic variant has very low. This is statistically significant and provides us 84 accuracy. In regards to amygdala, we can see here that has the a very large differences between these two groups, and which is very significant, as the same level of significance, but here visually you can see that the semantic variant, in particular the amygdala, is very atrophied. The volume is very reduced compared to the same aged patients with only cognitive impairment. Therefore, and to conclude, I would like to say that these results show that the hippocampal atrophy is not only related with Alzheimer's, especially when we compare Alzheimer's disease with other type of dementias. And therefore, for differentiate this disease should be also used other type of regions, namely the cortical regions. And as I've been saying, that nevertheless, Alzheimer's disease versus behavioral components share very similar changes in the hippocampus and also the cortical region. That's why we only got 64%, 65% to discriminate these two regions. And I would like to say that the hippocampus only allow the discrimination of the mild cognitive impairment, ID-related, and the semantic variant. And the atrophy of this region can be very subtle. So further studies must be related with studying Alzheimer versus mild cognitive impairment in these regions and these other dimensions as well. And you can see the interesting that amygdala was quite important to discriminate mild cognitive impairment from the semantic variant as well. And since we got only a very small data set, studies with larger samples are needed to validate this finding. And if you want me to contact me, if you have any other questions, please free to reach me out through this email. And you can also check our Institute of Biophysics and Biomedical Engineering here in the University of Lisbon. So thank you very much. If you have any questions, please reach me out.